about 3 o'clock, so I guess it's time to do the thing. What's the all or none law of the nerve impulse? The all or none law says that if it fires, and if it doesn't fire, it doesn't fire. But the height of the spike is independent of the stimulus. The number of spikes you get might depend on the stimulus, but the magnitude of the spike, the voltage of the spike is independent of the stimulus. What's an inhibitory synapse? I'll start drawing them like this now. So before I was drawing a more complicated picture of the cell. This will be the cell body, this will be the axon, this will represent the synapse. If this is cell A, we stimulate A, that causes a train of spikes to travel down the axon to cell B. If when you stimulate A, the firing rate in B increases, that's an excitatory synapse. And if when you stimulate A, the firing rate in B decreases, that's an inhibitory synapse. And so an inhibitory synapse is one where stimulating A decreases the firing rate in B. And this synapse right here would be categorized as an inhibitory one. Any questions about that? First two. Okay, compare the speed of the nerve impulse. So the speed of the nerve impulse in an unmyelinated fiber is 1 to 2 meters per second. That's way slower than the speed of electricity. Speed of electricity is comparable to the speed of light. That's 300,000 meters per second. Speed of electricity and speed of light are about the same. Speed of sound is about 430 meters per second, about 700, a little over 700 miles an hour at sea level, depends on the altitude you're at. So it's much slower than either of these two. Now the difference between these two, you notice when you see a flash of lightning and then you hear the thunder, because the light gets to you way before the sound does. So sound travels slower than light, and you notice that when you have a lightning storm, but nerve impulses are way slower than that. Myelinated fibers, the speed might be as high as 800 meters per second, which is much faster. All right, what does Calit say about this argument if some trait is determined by heredity? He says, well, there's one where we know absolutely. PKU, phenylketonuria, is a condition produced by a single recessive Mendelian gene. It's carried by about 2% of the population. If these two people marry, their children might get both copies, right? So 1/4 of their kids. If they have one recessive, you have two people, each of them carries a recessive gene, right? Then it's possible 1 out of 4 is going to get 2 copies of the recessive gene. They're going to be a phenylketonuric. What happens in phenylketonuria? The person accumulates, cannot digest a certain protein, and they become, well, they end up with a lot of medical problems, including severe mental retardation. So a huge gap. But what can you do about it? You can change the person's diet, in which case they don't have mental retardation. So here's a case where we know something is produced by heredity. We know that this heritable trait can have a profound effect on IQ, among other problems that phenylketonurics have. But by changing the environment, you can do something about it. And so when we know that it's produced by heredity, that's the one case where we have the biggest effect of environment on IQ. And so the argument is not a correct argument for that reason. Yes, there was a question.
Oh, I already knew about that, so I was gonna say about the whole, if you put them on a diet low in phenol, then they don't
Yes.
become.
So by making a change in the environment, you put the people on an environmental change, then they do not, if you're really good at it, which is a problem with diabetes and other conditions like that, other allergies. If the person is really good at monitoring what they eat, they would have normal intelligence. So you're talking about what might be a 40-point IQ difference produced by a change in diet. And so we don't have 40-point IQ changes. We don't really know what to do with the environment to make a 40-point IQ difference, except in some cases like this, PKU, phenylketonuria. PKU or phenylketonuria It's described, it was the homework assignment to look up in CALIT. So how many got that? So you did the homework and looked it up in CALIT, you found that if you're able to find it in there. So it looks like a few more folks found it. All right, any questions about the quiz? Question number 1 through 4 here. And for those that came in here a little late, any questions about the announcements? So now's a good time to finish the SONA. If you want to do experiments, this is the time of semester to do them because the opportunities drop off right at the end. So at the end you'll be writing papers instead of being in experiments if you wait till then. The bonus got awarded, so go check your account. If you had 2.5 hours by the midterm, then you should have found a bonus credit. If you're in there, and Psych Day is Tuesday morning at 9. We will meet in class because it's done. Basically, everything will be done by 2 o'clock, so there's no conflict with class time in here. All right. Let's do a quick